All right, this video is on continuous compounding and also the difference between nominal interest rate and effective interest rate. So the important formula to learn for today is I sub e equals e to the r minus 1, where r is the nominal annual interest rate. R is the nominal, that means in name only. That's also, nominal rate also can be called stated interest rate, contract interest rate, annual percentage rate, but it's in name only. It doesn't necessarily equate to how much cash you'll end up paying or receiving in interest. So R is the nominal annual, so for a whole year, interest rate. So let's look at an example. We want to translate an annual percentage rate, nominal, to, it's 12%, to its effective annual interest rate, and it's invested or compounded, we should say compounded continuously. Compounded continuously. Okay, and the effective interest rate then is always going to be higher than the nominal rate, and the effective interest rate is the one that determines, that's the rate that determines how much cash is paid or received as interest. So we are interested in the effective interest rate. So for this example, I sub e, or effective interest rate, equals e, and that's e on your calculator, e to the x on your calculator, and x we're using r, as x is r, the nominal annual interest rate. So put in the 0.12 for the e to the x, and that it stands for 12% interest rate. And then subtract 1, and your calculator will give you a number with the decimal point over here, but then it's percentage, so you just move the decimal point over. So the annual nominal rate is 12%. The effective interest rate is 12.75 almost percent, and that will determine how much cash interest you pay or receive. All right, let's see how to do nominal and effective interest rate translation in Excel. So in Excel, if you have a nominal rate and you want to find an effective interest rate, then you would put into the cell where you want the answer the equal sign, EFFECT, effect, parentheses R, comma, M, parentheses. And R, remember, is the nominal rate, the nominal interest rate that you're given, and M is the number of compounding periods per year. Per year. Okay, and that's what we'll do in this little example here. So I've got a little snippet of Excel right here with column A and column B, and I've got 4 rows in my little Excel reference sheet, and I'm going to be entering values into column B. I've just put column A here for you to show you what, to tell you what the values in column B represent. So we're given a nominal interest rate R of 4.41%, just for an example. Nominal annual interest rate 4.41%. Number of compounding periods per year, that's letter M. We're going to say this in this example, the interest is compounded monthly, so there are 12 compounding periods per year. And then the effective rate, I sub e, we want to show up in this cell right here. This cell reference is B4, right? So into B4, we're going to type equals effect, parentheses, cell reference B1, which is the nominal rate. So we actually type into Excel B1, or just click on that cell to reference that cell, then a comma, and then cell reference B2, which is M, the number of compounding periods per year. Ending parentheses, push enter. And the answer that should appear here is something like 0.045002. If you want to try that on your Excel, you should come up with 4.5% effective annual interest rate, when nominal rate is 4.41 and it's compounded monthly, 12 times per year. When the interest is only compounded once a year, the annual rate, the nominal rate and the effective rate will be the same when interest is compounded once per year. They're the same. But when interest is compounded more frequently than once per year, then the effective interest rate is always going to be higher than nominal. And the effective interest rate, again, is determines how much cash is actually exchanged hands. So you want to pay attention to the effective interest rate. If you're given, the other example, if you're given, if you're given an effective rate and you want to turn it into the equivalent nominal interest rate, then you type into Excel equals nominal, parentheses, I sub E, the effective rate that you're given, comma, M, number of compounding periods per year, closing parentheses, and then into Excel like this, and then what you'll get then is the equivalent nominal interest rate.